In this video, we're going to look at how to convert between the vector equation of a line, the parametric equation of a line, and the Cartesian equation of a line. What I've got written down here is the vector equation of a line. And we're going to convert this to a parametric equation first, and then we're going to convert it to the Cartesian equation second. And this is the usual progress down as you convert from one to another. Now, the parametric equation isn't too bad because it's not too dissimilar to the vector equation. So for the parametric equations, the way we set it up is we know that this position vector r here has an x component and a y component, and that's going to equal, and I'm just going to combine the x terms and the y terms in their respective rows here. So 2 minus 3 lambda, so 2 minus the 3 lambda there, and then for the y component we have 1 plus 2 lambda. 1 plus 2 lambda. The next step is the easiest one. So to go from the vector to the parametric, I just need to have an x equals 2 take 3 lambda and y equals 1 plus 2 lambda. These equations here are called the parametric equations. Now, in this case, we were looking at a two-dimensional case with just x and y. Obviously, if we had x, y, and z, we'd have the z here as part of the third parametric equation. Now, why is it called a parametric equation? That's because we're dealing with a parameter. And in this example, the parameter we're dealing with is lambda. So it's a parametric equation because the parameter that defines our x and our y is the lambda value, and that's why that's called the parametric equations. The third type of the Cartesian equation is the most commonly known one. So for that one here, what we do is we take these parametric equations and we solve each of them for lambda. So in the first example, we've got x equals 2 take away 3 lambda, and I'm going to solve this to have a lambda equals. So in this case, we're going to have 3 lambda equals 2 minus x. Lambda equals 2 minus x divided by 3. Then I'm going to do the same for the y value there. I've got y equals 1 plus 2 lambda. At this point here, if it's simple enough, what you could do is you could just substitute this value of lambda into that value over there if you really wanted to. But I'm not going to do that. I'm just going to solve this one for lambda as well because it's just good practice. We've got 2 lambda equals y take away 1. So lambda is going to be y take away 1 over 2. Then we've got a lambda equals y take 1 over 2. And we have lambda equals 2 minus x over 3. But we know that these two lambdas have to be the same because they are on both part of the same line. So what I can do now is I can write 2 minus x over 3. Should be the same as, because these two lambda values are the same, y take away 1 over 2. And you can simplify it from there, but this is the Cartesian equation because we don't have any more parameters, so we're not talking about our lambda as our parametric equations. We don't have it as a vector, we've just got the equation in terms of x and y. Now you could simplify that for yourself later on. The way I would do it is I would just times both sides by 6. So I'm going to have 4 take away 2x equals 3y take away 3, and then I'll simplify it to get my y equals equation there. So 3y equals minus 2x plus 7, the y equals minus 2 over 3x plus 7 over 3. Using the information that we just went through, let's look at another example. Find the vector equation, Cartesian equation, and parametric equations of the line through that point that is parallel to this vector over here. So the first thing I'm going to do is we're going to write it as a vector first. And you can see that this is a three-dimensional case. So we know that the vector of the line, we need a point on the line. So I'm going to choose this point here, A, 1, 2, and 1. And we know that it's parallel to this vector here. So it's got to be going in the same direction as this vector. So it's minus 1, 2, and 1. So that's my vector part done of the question. The next part we have to do is we'll look at the parametric equation. So they've said do Cartesian second, but I'm going to do the parametric one second. We know that we can write our vector r in terms of its x, y, and z components. And we're just going to group together the x components again. So it's 1 take away lambda, 2 plus 2 lambda, 1 plus lambda. Okay, and then from here we can get our parametric equations of x equals 1 minus lambda. Our y value is going to be 2 plus 2 lambda. And our z value is going to be 1 plus lambda again. So this is my vector equation. These three here make up my parametric equation. And we'll use these parametric equations to help us determine the Cartesian equation. And again, we just break it up into the three components, and we solve each of the three components for lambda. These are called parametric equations because they have a parameter. That parameter is lambda. So let's start off with the x there. X equals 1 take away lambda. Therefore, lambda is going to equal 1 take away x. That's for the x value. Now we'll do the y values. So we've got y equals 2 plus 2 lambda. When we solve that, we're going to get lambda equals y take away 2 all divided by 2. And the third equation is z equals 1 plus lambda. And when we solve this, we're going to get lambda equals z take away 1. This may not be common because we're used to dealing with a y equals something to do with x. Like in the previous example, what we had was y equals mx plus c. So we're used to seeing it in 2 dimensions, the Cartesian equation. The Cartesian equation of a line in 3 dimensions looks a little bit different. Okay, but it's the same process. We're going to have this value of lambda equals that value of lambda equals that value of lambda. And I might even use the subscript x, y, and z. Okay, I've just added that in there at the end there so you know what I'm talking about when we talk about the Cartesian equation. So what we're going to have is we need lambda x equal lambda y to equal lambda z. In the previous example, we just had lambda x equals lambda y. But in this example, we have to add in that lambda z there. So lambda x is 1 minus x. Lambda y is y take away 2 divided by 2. And lambda z is just z take 1. Now, this equation over here, this is the Cartesian equation. Because we have our Cartesian coordinates x, y, and z, we don't have any more of the parameters. Okay, it's not a parametric equation, and it's not written as a vector. So the usual progression going from vector equation to our Cartesian equation is we use the parametric equation as a buffer zone between the two. Alright, let's try one more. Find the vector and Cartesian equation defined by the parametric equation. This one's a little bit different because what I've done is I've given the parametric equation, and we have to work backwards to get the vector equation and forwards to get the Cartesian equation. So again, what I've done is I've given us the mid-level solution, and we're going to work backwards to get to the vector equation, and we're going to work forwards to get to the Cartesian equation, just like we did before. When I look at this, I'm going to put this into vector form first. So I know that my x, y coordinate, I'm just going to write it as a vector, is going to be 2 take away lambda, and 3 plus 2 lambda. Okay, and we can work straight back towards our vector equation of r equals a. Now a in this case is the point that we're looking at there. So it's going to be 2 and 3 plus lambda. And the lambda values are -1 and 2. So this is the equation of a line passing through the point 2, 3, parallel to the vector -1, 2, or it goes in the direction of -1, 2. That's for the vector equation. Now we can, that's working backwards. Let's work forwards now to get to our Cartesian equation. Again, when we're solving for the Cartesian equation, we're actually going to solve for lambda in both cases. So let's do the x one first again. X equals 2 take away lambda. Lambda equals 2 take away x. And again, I'm just going to use a little subscript there. You don't have to use that, but I'm just going to do that to illustrate to you where each lambda is coming from. And then we've got the y values. So y equals 3 plus 2 lambda, which means that lambda for the y's is going to be y take away 3 divided by 2. And to get rid of these parameters, the lambdas, we'll make our lambda x equal to our lambda y. So 2 take away x is going to equal our y take away 3 divided by 2. And because this is a two-dimensional linear equation, we usually like to write it in the form y equals mx plus e. So I'm going to get rid of this divide by 2 first. And then we'll move the 3 across there, and what we get is y equals minus 2x plus 7.